Right, good afternoon, Year 8. Welcome back, and hope you enjoyed the satellite documentary that I asked you to look at over the Easter holidays. I've left it on, so if you still haven't quite finished it, you really do need to finish watching that and make sure you have your notes about how satellites are actually used and how they work. We're nearly at the end of the space topic, so we've got two more lessons. So what we're going to do today is we're going to examine how telescopes work and what the possibility of alien life is based on where sort of planets are in the solar systems. So all of you should be able to describe how a refracting telescope works. Most of you have to explain how refracting and a reflecting telescope work and suggest if alien life exists. And a few of you will be able to explain in detail how telescopes bend light to focus images and calculate the odds of there being intelligent life. Although this last part we may bump into next lesson. Right, so the first thing I would like you to do is if you go into files, there is a sheet which asks you to match up the word with the description. Okay, so what I'd like you to do is you can either print that sheet out and cut them up and match them up. And then stick it down into your book. Or if you want, you can simply copy them into your book by matching them up. Once you've matched the word description, you then need to put them in the order of size, going from smallest up to the biggest. Okay, so by the time you write all those down, and by the time you have worked out order from smallest to biggest, that should probably take you about 10 minutes. So pause the video now and please do that. Thank you. Okay, welcome back. So there are two types of telescope, which I'm going to show you how they work. And essentially this is what we were going to do in the class as an experiment. And hopefully when we come back, we will get an opportunity to do this. So what a telescope does is essentially it magnifies very faint, very distant light so that you can actually see things at a great distance. So the first type of telescope we're going to look at is this one. Now this is called a refracting telescope. Okay, now it's called this because what it does is it refracts light. Now if you think back to what you learned in year 7, you hopefully remember that when light goes through something which is made of a different material, like glass for example, it changes direction, it bends. Okay, and if the glass is of a specific shape, it will bend in a specific way. So I'm just going to explain to you how that works. So what happens is, if I just show you here, when a beam of light comes in at an angle, okay, here it is, when it hits the glass block, because the glass is denser than air and it's heavier to get through, it kind of forces it to change direction. It goes like this, and then eventually it'll go back to its original path like that. So the beam of light will go dum, dum, dum. Now you see here, the beam of light hits a flat surface. And what happens is, if it hits a curved surface, it's like that little section is a flat surface. Okay, so the beam of light comes in, but when it hits there, it refracts like that. It seems it changes direction. Okay, now here, it's as if hitting it like it's straight on. So if a beam of light comes through here, it'll go in, go straight through like that. Well, because this part is vertically flat, it's pretty much the same. So that goes straight through like that. And then on this side, it will bend in slightly like that. And you can start to see what happens to the light. They all start to focus at this point. So what a lens does is it changes direction and focuses the beams of light onto a point, which we're going to talk about a bit later. So what happens is light comes in a straight line, and then when it hits the lens, what will happen is it will bend the light inwards towards a point here called the focal point or the focus. Now, what happens, the reason this works is it takes very faint, very distant light and essentially concentrating it, focusing it all to a point. Can everyone see what this first lens is doing? Now this is called the primary lens. Okay, so the job of your primary lens is to focus very faint, very distant light, sort of like concentrating it. However, the problem is, if we did that, the light would be very out of focus. So what we need to do is light has to travel in parallel lines like this. So what we need to do is we need to get it back to being parallel. Now, what we do with this is we use another lens, and you can see here, this lens bends ever so slightly outwards. Okay, now what that does is it bends light in the opposite direction, not inwards, but ever so slightly outwards. But because the light was going inwards, when you bend it outwards, it actually just puts it back to being straight. So now we've got a nice focused image of concentrated light that goes in. So all this light, which is very faint coming from here, you can see has been concentrated and been put back parallel, so the image will be nice and focused. So here comes the tricky part. What I would like you to do is I'd like to spend about 5 minutes, 5, 6, 7 minutes, copying this diagram into your book of how a refracting telescope works. I'm just going to put the name up here for you. So this is a refracting telescope, and it's called refracting because what it does is it refracts the light. Refracting means bending. So it refracts or bends the light first through this lens to bring the light together, to focus it, to concentrate it, and then through this eyepiece lens to bring the beams of light back parallel, so we get a nice focused image. Okay, so pause the video now and draw this into your book, because this is how we see very distant objects in space. Okay, I'll just move this down ever so slightly so you can have these two descriptions here, but take about 5, 6 minutes, draw this into your book, and then make sure you've explained in your own words how this works so that you can understand it. Okay, off you go, please. Okay, so this next type of lens, not lens, sorry, telescope is called a reflecting telescope. Now, this was invented originally by Isaac Newton, and I'll just explain how it works. So, if we're looking at a distant object, such as a distant planet or a distant star, the light will come in, as it does with the refracting telescope, you can see here as parallel beams of light. But rather than using a lens to focus the beam of light, we use mirrors. But these aren't ordinary mirrors. As you can see, they're concave. They have a curve here. Now, what that does is it focuses the beam of light onto a second mirror and then out through a lens. Now, this would actually be, this isn't a very good diagram because this would actually make the beams of light go parallel again. So just you might have to correct that yourself. So what happens is rather than using a refracting lens to focus the light, you can see here lots of distant, very faint line, all traveling in straight parallel lines here. It comes in, it hits the mirror, but it's all focused. So it's all coming together, being concentrated again, and then out through this mirror and out through this lens, and then your eye would be there. Okay, now this is actually a much better design of mirror because it doesn't give you any kind of blurry, what they call chromatic aberration. Okay, whereas unfortunately the refracting telescope does. So I'm just going to very quickly explain how the reflecting mirror works, and then you're going to draw this one up as well. So a minute ago I showed you how lenses focus light. If we do something similar with this, now hopefully you remember that when a beam of light hits a mirrored surface, it will reflect, and the angle of incidence is equal to the angle of reflection. So basically, whatever that angle is, the beam of light coming in, is the same as that angle, beam coming out. I haven't drawn this very accurately, but you get the idea, I hope. Okay, so with a reflecting telescope, what happens is your beams of light come in, but as you can see, this surface is curved. Now, as the beam hits that point, it would be as if it was hitting a flat surface, but it would be like that. Now, if I just draw in your line here, the reason I draw this little dotted line is it's to help you work out what the angle would be. So that point there would be like a flat mirror. Okay, so as the beam of light comes in, it hits what it believes is a flat surface and comes out at the same angle. Now the beam of light here just quickly go back to that, that's fine. Right, so another beam of light comes in, and the same thing happens over here. It hits the mirrored surface and bounces off. And you can see, you get a very similar effect. The beams of light, just like they do with the refracting telescope, all focus to a point. Okay, so a curved mirror can have a similar effect to a curved lens, a curved piece of glass, essentially. What they'll do is they'll focus light onto a point. So, back to our telescope. This one is going to be a bit more challenging because what I would like you to do is now draw this into your book and label and explain, probably about 2, 3, 4 sentences should be fine. Explain how this mirror telescope actually works. So let's go through it one more time. Parallel, very faint, very distant beams of light come in. They hit a curved mirror, and as you can see, the beams of light start to focus inwards. They get concentrated. They're bounced off another mirror and then out through a lens. And again, this is slightly inaccurate. When they go through the lens, they would actually go back parallel like that. And then your eye would be about there and you can actually see what they've done. Okay, so pause the video now and please copy this up into your book with an explanation, 3, 4 sentences about how it works, please. Off you go. Okay, so this next section, I would very quickly like to write down these 5 questions in your book, and please leave a little bit of space to answer them. Now, some of them you'll be able to answer based on what we've learned in class from last term. Some of them you might need to quickly jump online and try and figure out the answers for yourself. So this will probably take you about 10, 15 minutes to do this if you're doing it properly. So, first question, what telescopes are used to look for in space? List as many things as you can. Okay, so again, some of those answers will be based on previous lessons, some of them you can look up. Who used a telescope to observe Jupiter first? Okay, now you're going to need to definitely look that one up. I don't think you would have that one yet. What did this person actually discover? Okay, now it's quite a famous person, you'll recognize the name, but what did this person discover? The first person to look at Jupiter properly with a telescope. Explain what telescopes are designed to do. You've sort of covered that already, so maybe just a very brief explanation of that. And then finally, do all telescopes use light? If not, what else do they use or look at in the sky? Okay, so these are your 5 questions. So please write down these 5 questions now. Okay, and then try and answer them as best you can. Maybe leave a few lines in your book to make sure that you can actually do that. Okay, once again, pause the video. Have a go at that now, please. Okay, so last task for today. Do you think aliens exist in our galaxy? Discuss and explain your reasoning. Okay, so this is quite a tricky one because we have scientifically absolutely no evidence either way. However, it is really interesting to speculate about this. So once again, I'd like to write down this question, and then on the chat group, and I'll be involved in this, I'd like to discuss what could be our reasons for this. Okay, so do you think aliens exist in our galaxy? And if so, why? Okay, what would be our reasons? Now, we need to think valid scientific reasons for this, okay? And then once we've had our discussion on the chat group, what I would like you to do is I would like you to write about a paragraph, so about a third of a page probably, outlining your reasons why you think there is or is not likely to be alien life in our galaxy. What are the difficulties that life has? Okay, and then in the next lesson we'll go through an actual mathematical equation to try and calculate the odds of this. Okay, so firstly, let's jump on the chat group and see what we can do. Okay, this will actually be the last slide, so I'll sign off on the chat group once we've finished, and then you can write up your reasoning after that. Okay.